Hello, everyone. Welcome to WPPM podcast, Wind Power Projects Management Master's Program at Campus Scotland, Uppsala University. And we are delighted to have Frauke Wilberts, a passionate wind power and language enthusiast with an extensive background in project management, consulting, and mechanical engineering. We are very happy to have you, Frauke, here. You are a former student of this program. And can you please give us a bit more about your background and what are you doing these days?
Yes, sure. Thanks for having me. I probably should have updated my LinkedIn headline. I didn't know it was going to be used. But it's still accurate. Yes, hi, I'm Frauke. I finished the master here in 2017 and I did the one-year program. I studied mechanical engineering before that, and I studied shipping and chartering before that. So it's basically a bit like ship management and how you deal with vessels on a daily basis. And then I diverted to the mechanical engineering because I found the technical topics much more interesting than the other things. And in the end, I've always wanted to work in wind power since I'm from Alborz, a small town in Germany, and that's the headquarters of Enercon, an onshore turbine supplier. So I'm a bit biased regarding wind power because I saw this everywhere around me when I grew up. Yeah, and now I'm working in offshore wind power. So first I started out in onshore wind power, and over the years I developed into offshore wind power. And after I finished my master, I worked for Accenture, which is a management consulting company, for a while. That was just a short excursion, which I didn't continue. And then I missed wind power a lot, so I started working for the Belgian wind farm developer Procurement, and worked there in the turbine package for 2 years for developing a wind farm in Germany called Arcades Ost 1. And then during COVID, I changed my job. I moved back to Bremen, where I studied before, and now I'm working for Skyborn Renewables. That's formerly known as WPD Offshore, and since last year September it's called Skyborn.
Mm-hmm.
And there I was also working for the turbine package, mostly for the Taiwanese project Yunlin, for a project that's in execution right now. So we are building the wind farm right now in Taiwan. And since May I actually changed my job within Skyborn, so now I'm working as an interface manager for the company.
Okay, what is exactly an interface manager?
Good question. So, as an interface manager, you need to have an overview over the whole project. So you're not looking into one specific technical package like I did before with the turbines, very specific, but you need to check the connections between the turbines, the foundations, the cables, the substation, or whatever you have there for the electricity. And also the other parts of the company, like the contracting part, financial part, procurement, everything, like all these things you need, certification, design, for finishing a project. Because all of these different packages, all of these different areas of work, they have connections and they have overlapping things, scope. Like, for example, you have a little crane on the platform of an offshore wind turbine, the David crane, and there's an interface between the turbine supplier and the foundation, because the turbine supplier, maybe if it's in your contract, buys the crane, and the foundation designer needs to know what kind of crane is there, where are the cables running, how is this connected, who installs it, like when does the turbine supplier install the crane, or do we install the crane where we install the foundation, and so on. So these are very technical interfaces, and there are also non-technical interfaces like communication with authorities, stuff like that. And as an interface manager, it's your job to keep track of these interfaces, to keep track of decisions regarding interfaces. So every time there's something that affects more than one package, then you need to have an eye on that it's clarified, so that in the end you don't have any gaps in the scope. So in the end, we need this crane on the platform, so you need to make sure that someone's buying them. You don't really care, or maybe you care, but you shouldn't care that much about like who's doing it, but it should be done by someone. And it should be clear to all the people working in the packages and the contractors that they know what they are doing and what they're not doing. on where they're responsible, where they're not. So it's interface management. So like defining the scope, discussing the scope and making clear the scope is clear to everyone. And then following up with the scope, and if there are changes, the changes need to be communicated to everyone. And if there are decisions, then it also needs to be clear to everyone what's the decision and what do I need to do and what do I not need to do.
Okay, thank you. Let's go back and let's just talk about turbine procurement.
Mm-hmm.
What are the challenges? What are the trends?
Well, the trend is, and it's also a challenge, that turbines are getting bigger and bigger offshore, and that they are growing bigger at a very fast rate.
Mm-hmm.
So you cannot rely on a turbine model staying around for like 5 years or something, but you're more buying something that doesn't even exist yet. So the turbine suppliers are like, this is our newest model. If you want to build a wind farm in 5 years, 6, 7, 8 years, then we'll have this model available, and no, the current model we're using is not going to be available anymore because we changed all the fabrication, we changed everything to this new model. So you're basically buying something that hasn't been tested yet, that's not there, it doesn't exist in reality, just in a computer.
Yeah.
And they have good simulations and very nice 3D models.
But no track record, so.
But no, nothing you can touch. It's not really there yet.
Okay.
But that's not the only challenge, but one of them.
One of them. How about logistics? During the lecture that we had, you mentioned that logistics for offshore is a little bit easier than onshore.
Yes.
But I would say it should be more challenging because we are talking about huge, expensive vessels. We are talking about huge turbines. They are getting bigger. Vessels are, I don't know if they are getting bigger like in the same pace.
Yeah.
What do you think about it?
It's like, I didn't want to say it's easy, but it's easier in a way that the logistics already exist.
Yeah.
Like heavy lift, heavy transport, it's already existing. So it's not like wind turbines are the heaviest thing that's ever been lifted in the marine world. There's oil and gas as a big industry since years, and they've lifted far bigger things and transported far bigger things than wind turbines. So wind turbines itself are not that big. It's the substations that are really big. And they have years of experience in doing this. So from a logistics point of view, it's already much more established. Of course, it's still not easy, and it's complicated, and many things need to work together to make it function. But there's a lot of experience already in how to do this. And if you compare to onshore, for example, if you want to build a wind farm somewhere remotely with a bit of hills, and you need to pass some villages or something on the way, and you need to transport those big rotor blades, it's just super tricky to get a rotor blade there, just one, and you need to do this several times. And that's what I mean. It's easier, the logistics, because you have heavy lift vessels that can transport several blades at one time, that can transport several foundations, several tower segments. So that's all. It's well established. That's why it's easier.
Okay. What advancements in wind turbine technology can enhance offshore wind projects' efficiency and cost effectiveness? These are the questions that I received from the students.
So I'll blame on them.
Yeah.
Okay, make turbines more efficient. Not that I didn't receive the questions before. Well, the rotor sizes are getting bigger, so you get more electricity out of that.
Mm-hmm.
You are more efficient then if you say, like, per turbine, how much can I produce? So for a certain amount of megawatts, you don't have to build that many turbines to get a certain output of electricity. That's good. What else do they do? I mean, they're always trying to tune the blades to make it even more efficient, to make the generator better for the ones using still a gearbox, making the gearboxes more reliable. They're doing a lot about O&M, like how often you have to intervene, how often you have to go offshore to do repairs, to do the regular maintenance, and so on. So that's a big factor to keep the costs low, to reduce the offshore part as much as possible. Not only doing O&M, but also doing the installation. So if you want to avoid costs, you try to do as much as you can onshore. Because that's a lot cheaper than going offshore. Everything offshore is associated with a sort of a risk, and it can get expensive. If you have weather downtime, you need to wait, something breaks down, you have a failure, and you need to troubleshoot or something, then offshore it's always much more expensive and much more complicated than onshore. So that's, I think, that's one thing they focused on, is to do, like, preload the tasks from doing everything, or doing a lot offshore, doing a lot onshore as much as you can, prepare as good as you can. So once you're offshore, everything just runs according to the process, and you don't have to fear that, you will get stuck or something. But of course it still happens.
Yeah. Also, offshore is, now we can say that offshore is a major technology. So CapEx and OpEx is coming down. Still is coming down, right?
It has been true for the past years. I'm not sure right now. The situation is a bit insecure.
But what will happen if the electricity prices goes down again?
I think it's just a lot of pressure on developing projects. It's a lot of pressure on the auctions and what price you put into your bid, and that you are still competitive without. That's like, as when you're put in their statistics from last year, is that the investment volume actually went down last year for offshore wind because of this not stable market, and not sure about the supply chain, and not sure how the industry will look in a few years. So I guess 2 years ago everyone was quite sure about that, and now since last year they're not that much anymore, and that's postponing some projects. So they actually postponed some of the final investment decisions for some projects.
And they're waiting for something, but what is that?
I guess they're waiting for the market to stabilize, to be able to rely on your supply chain again, that the materials are available at some price that you can afford. I mean, that was for everything. That was, so I tried to buy a new bike. Maybe in 6 months it will be available. It was just a random bike, and it was the same for, I don't know, washing machines or whatever. And it's kind of the same for turbines. It's not like they all come from one European country and they're all built locally. It's a lot of technical parts coming from all over the world, and you need to have all of those available.
Yeah, okay. Let's go to the next question. What are the major challenges faced in the offshore wind industry, and how are they being addressed? So you covered a little bit, but do you want to add something?
So there's the one we just covered, would be like stability and prices. That right now you cannot even get a reliable price for a turbine. So it's very volatile, and you cannot really rely on a price for 6 months or something to stay stable, or 3 months, but it's like changing a lot. That, I guess, makes it also harder to find investors for your projects, because of course they want to know the price tag, and they want to know how much they invest and how much is their return. And if they feel like, okay, it's not a given, I cannot really rely on it, then it's hard to find investors. On the other side, everyone wants offshore wind power, and we want to have renewable energies replacing the traditional ones, and it's not so easy right now.
Yeah, okay. Let's talk about the trends now. What are the future trends and developments in offshore wind, both in terms of technology and market outlook?
I'm also stealing from the Wind Europe report now, I think. So it's offshore wind is really getting on this step to be full-scale power plants. So you really can replace power plants that used to be onshore, the traditional ones, by an offshore wind farm. So it's a lot about standardization, really making them big, like 1 gigawatt and beyond, to have that as a standard size, to have all the vessels and everything in the certain size available. The turbines are still getting bigger, and everyone's waiting for that point where the manufacturers say, okay, we're not gonna build a bigger model, but so far they always did. So it's difficult to say, like, okay, now we reached the threshold of, like, this will be the biggest turbine, and then nothing bigger will ever be built. So far the trend has been always another model, like every 2-3 years, bigger and bigger. So maybe that will stop at some point at 20 megawatt.
I mean, people are now thinking about 32 megawatt turbines. I saw a project on 32 megawatt. It was crazy.
Yeah.
So is there a limit, really?
Well, there must be some sort of a sweet spot, an optimal spot where it's not worth it anymore to make it bigger because the whole structure needs to support this monster of a wind turbine. It's like colleagues of mine went to see I think it was even the 11 or the 14 megawatt turbine of Siemens Gamesa. And they were just like, it looks like a house. It's like the whole cell. It's just so big. So you cannot imagine that it can get even bigger and that the rotor can also be bigger. So I think at some point the question is if the material can still do this.
Yeah.
But so far they've advanced a lot in the material as well. So yeah, let's see. I mean, you can design a lot, but doesn't mean that it's feasible for a project to be built.
Okay, next question. What are essential strategies for maximizing the reliability and minimizing downtime of offshore wind turbines in O&M?
You should really have a colleague from O&M. Okay. Well, something that they really managed over the years is to bring down the amount of time you need to spend, or not the amount of time, but actually how often you need to go offshore to do maintenance. So like the maintenance free, it's not maintenance free, but it's like super reduced maintenance, like one annual service. In offshore wind, they started with, I don't know, you had to go there every few weeks, I think, to refill something or check something.
Mm-hmm.
And nowadays, you don't have to do it that often, actually. You have super reliable models that can run for a long time and don't have any failures. Then, what was I going to say? Oh yeah, you have more advanced condition monitoring, so you have those sensors everywhere in the blades and on the gearbox if you have one on the generator and so on. So you can remote control a lot of the things, so you can monitor from some monitoring center somewhere in the world. Doesn't even have to be the same country you have your wind farm. And these error codes that you get from them, or those values that you can read from them, you can already see what's going on, and you can see, is it worth it actually to go offshore? Is there a problem? Or if we don't do anything about it, will there be a problem soon? Because, I don't know, some loads are always too high or whatever. Or it's just a sensor failing maybe.
Mm-hmm.
And then you can already prevent a lot of what could be then a real maintenance case. If you really look at those figures, you can find out early, okay, we might have a problem there. So next annual inspection, you check specifically for that.
Okay.
So I think that's a big thing of advantage of digitalization, that you get all this data and you're actually able to process all this data as well.
Okay. Can you suggest any hot trends and topics, especially for thesis, to our students?
Yes, I can. I prepared one. Yeah, I don't have a super specific topic or at my company or something, but I think it's good if you focus also to include IT in offshore wind farms and the project management for offshore wind farms, because as I see it right now, it's not so standardized yet. I guess it's more standardized than the floating wind, but it's not standardized like, for example, oil and gas sectors or civil engineering sectors are working nowadays to build offices or whatever. They have a super streamlined, super standardized process how to do this. And they also have the software working with that. So the software helps them to get along that process, to cover a lot of repetitive tasks, a lot of things that machines can just do better than the human brain, and which is also maybe a bit stupid for humans to do. Because for every project you need to do this again, and you're asking yourself, why am I still doing this with Excel? And why am I not using something more sophisticated? Because we have phones that can do a lot. You have all these apps to cover your whole travel and whatever. My bank is in my phone and all these things. But for offshore wind or wind power projects, I think there's still a lot of room to invent and to develop or program, even if you're good in that, or if you like it and want to learn it. To find new tools to make the projects more efficient and to work better and take off the super stupid tasks from the employees, and then leave the ones where you still need the human brain to the people to think about. So I think you cannot get around programming for long, or at least using an app. I mean, you don't have to program it yourself, but just thinking from that angle of how could I solve this maybe with an app or with a software.
Mm-hmm. Okay, thank you. And do you have any words with prospective students?
Yeah, I remember it's not that easy to get a job after you finish your master. Like you're all like, yeah, I did it, and it can take a while, and that's just, yeah. But I think it's just normal. Maybe you shouldn't look too much to the others or compare yourself like what's my progress compared to the others, because everyone has their own unique path and their own unique way to do it. And even if I do it a certain way, it doesn't mean that it's good for everyone else to do it that way, because it's your own unique way to find your way to what you want to do and which company you want to work for. Or if you maybe want to found your own company because you have a great idea for something, there's still a lot of room for innovation in wind power, I would say. And yeah, it doesn't have to be a classic I'm working for an employer thing. You could also stay in science. I mean, a lot to still find out about wind power. So yeah, but yeah, give it some time.
Yeah. Okay. This was for students.
Yes.
But people who are thinking about actually
Studying
coming
wind
to an
power.
island, yeah.
Yeah, that's true. So just do it because this place is amazing. It's yeah, it's been the best studying experience I had. I did these 2 bachelor programs before in Germany, and then I came here to Sweden to do the master. And actually, my expectations weren't like super high, also not low, but I didn't expect that much from it. But it was really nice, especially compared to the German system of university. Is that you have a small class. You know everyone personally. You know all the teachers personally. They know you as well. You have small groups. The lectures, at least when I did it, were organized so that they're very practical as well. You have the project work to work together. Just like for us, it was 5 people, and then develop your own wind farm, kind of onshore. But okay, hey. You do a lot of hands-on work, and it's not so theoretical. And of course, the thesis is then can be very scientific if you want to, but it doesn't have to, and it can go so many different directions. And I really love that we had so many people from various backgrounds. So before I studied engineering, and well, over 7 women and 145 students in total, and everyone was like engineering, and everyone had math as a specialization in their school majors, and so it was not a very diverse group, let's say it like that. And I loved it so much coming here and having people from like spatial planning. We had one coming from business. All sorts of different things. Like,
Yeah.
It was really great to be in a group that was so diverse and from so many different countries as well, to learn so much from each other as well. Not only from the official lectures and so on, but you really learn a lot from each other. You really have a strong bond. I think my class at least had.
Okay.
And you don't have a chance to go anywhere because you're on an island.
But there is a lot of thing to explore
Of
in
course.
this island. Yeah, so
It's just beautiful. You have
Yeah.
the seaside, and you can go running along the ocean. Amazing. I love it. And you just, I don't know, we just got very close as a group because everything is small here. You can just walk somewhere and bike somewhere
yeah.
and have a good time together and get through the stress of the assignments and the thesis together.
Yeah. Yeah. Thank you for your time and this interesting topic.
You're welcome. Thanks for inviting me.